whatever things that we are trying to discuss, right? We are going to have a Boolean function. We are going to have a Boolean function. With the help of this Boolean function, I can able to simply construct one circuit only. I can able to simply construct one circuit. It is okay for me. So okay. So if I am going to give certain expression for you, like for example, a b c bar d bar, a b c bar d, a b bar c bar d, a b c d, a b bar c d, a b c d bar, a b bar c d bar, right? So for this, can you able to construct a circuit? Can you able to construct a circuit? Yes. Finally, it is in what kind of operation? Sum of the products. When it is in sum of the products, I can able to construct a circuit in AND OR combination easily, right? When I able to construct AND OR combination easily, I can able to implement with the help of NAND realization also. NAND realization also, right? So here, this is my circuit. This is my Boolean function. If you would like to ask you to implement a circuit, what you will do? You are going to take this many number of AND gates. Am I right or not? For example, I am asking you to construct uh, a 4 input AND gate. A 4 input AND gate. Then what you are going to take simply, you are going to take one AND gate which is taking 4 inputs, and for this expression one AND gate, like this. How many AND gates are required now? Total 3, 3, 6, 7 AND gates are required, which is going to take 4 inputs. 4 input. So for example, if they are asking for 2 input AND gate, then what will happen? It will require more number of gates or not? Yes, fine. Is there any solution to reduce this expression? Yes or no? We already discussed, right? We can able to simply solve this expression so that you are going to get minimize this expression. So that for that minimized expression, if I am going to construct circuit, the output of this function is equivalent to the minimized function also, right? So try to minimize the function. So try to check here from these two terms, from these two terminologies. I am going to take out ABC bar as out. If I am going to take ABC bar as out, I am going to get D bar plus D, D bar plus D, right? And I am going to leave this as this AB bar, C bar D. From these two, can I able to take anything as a common? Yes. A, C, D. You are going to get B plus B bar. From these two, can I take anything as common? A, C, D bar. If I take A, C, D bar, you are going to get B plus B bar. B plus B bar. Finally, you can write, right? So D plus D bar means what? 1. So you will get the expression A, B, C bar, A, B bar, C bar, sorry, A, B bar, C bar, D, A, C, D, A, C, D bar. This is our next expression what you are going to get, right? Once you got, from these two common things, can I take the AC as common? Yes, right? So A, B, C bar, A, B bar, C bar, D. From these two terminology, I am going to take out the common as D plus D bar. So D plus D bar is equal to again 1, right? So if I rewrite the expression, A, B, C bar, A, B bar, C bar, D plus AC, plus AC, right? Now try to think, I am going to take out these two terms, can I take common as A? Yes, right? So if I take the common as A, you are going to get B C bar plus C plus A B bar C bar D, right? What is this expression? Can I apply what kind of principle? Distributive can I apply? Distributive. A plus BC means A plus B into A plus C, right? If I am going to do that, C plus C bar into C plus B, C plus B, I can write A B bar C bar D, right? So now C plus C bar means what? 1. So now I am going to again apply distributive property. Then what you are going to get? AC plus AB plus AB bar C bar D. C bar D, right? Now can I able to like simplify this expression again? So I will try to rewrite here. AC plus AB plus AB bar C bar D. Is there any chance to reduce this expression? What we can do? Can I take the common as A among these two? Can I take the common? Yes. If I take the common, AC will be as this. If I take the common of A, see, you may get question here. Sir, why can't you take the common for all? Yes, we can take, but we may stop there itself, right? I don't want to stop there itself. I want to minimize the maximum extent. So that's why I am trying to do this particular procedure, right? If I take the common as A, B plus B bar C bar D, right? What is this expression again? Again distributive property. A plus BC means, right? What you can do? Again you are going to get AC plus A of, what is the result you can able to get from this one? B plus C bar D. B plus B bar into B plus C bar D. So can I write like B plus C bar D directly? Yes. Try to again multiply AC plus AB plus AC bar D. AC bar D, right? Now again try to do with the combination of these two. I hope you understood now, right? If I take the common of these two as A, C plus C bar D plus AB. Now what you are going to get? A into C plus D plus AB, which I can rewrite as AB plus AC plus AD. Is there any way to now reduce this expression? If at all, you can able to take the common as A and that's it. We can stop the expression, right? So this is the final minimized expression for this one, right? Basically, if you would like to implement this expression, you require 7 4 input AND gates and some more OR gates also, right? But if you take this expression, how many AND gates are required? 2 input AND gates are 3 and 2 input OR gates, I think 3. Am I right? So why you are getting 3? A, B, C, D. You are going to get one result. For this, one OR gate is required, and AD is you are going to get. For this, you need to have one more OR gate, and finally you are going to get the result. Okay. So 2 input OR gates are required also. 2. Right? This is what, right? So compared to this one, is it the best efficient one or not? Yes. Right. That efficiency can be in terms of area, or it in terms of power dissipation. Right, meaning that if you are going to construct a circuit, here how many levels you are going to get? 2 levels. Here also you are going to get 2 levels, but the way that is transferring the data is going to be more in the large expression. Am I right? And one more thing, when you are trying to solve this expression, is it difficult to solve this expression or not? It is very difficult to solve this expression, right? So as I know this is my result, so I am going to work on this way. But as a like you cannot able to get this result at a single stretch. Am I right? That is the problem. So at this situation, result may vary also. Result may vary means circuit design will compulsory vary.